2. It's 150 marks. It was meant to be done in 3 hours. Okay. So the instructions are, we have 10 questions that we need to look at. There's a special answer book that we shall be using. You must show calculations, and you must use some diagrams in some cases. Answers only will not guarantee full marks. There is a need for scientific calculator unless the question tells us not to use one, okay? So we need to round our answers to 2 decimals, and unless the question tells us otherwise. Diagrams are not drawn to scale, and there is a formula sheet at the end. Then we need to write neatly and legibly. Okay, so when you look at question number 1, it's usually statistics, okay? So in this case, they're telling us that the owner of a small company wishes to establish whether advertising in a regional newspaper is effective. Does it bear results? Okay. The table below shows the amount that was spent on advertising and the sales for the last 9 years. So the first year, the second, the third, and so on and so forth. So this is how much was spent on advertising. And then these are the sales, like the outcomes of the advertising after the advertising was done. Okay. So usually the amounts or the values in the top row will always represent the X. In this case, that told us those are the X values, and then these are the Y values as well. Then 1.1.1, they are telling us to determine the equation of the least square regression line. Okay, so one thing we need to know that for the regression line, it's usually in the form of Y is equal to A plus BX. Some calculators will show you these capital A's and the capital B's. And so what we need to do, we need to set our calculators into the mod function. From mod, we need to look at start. And then from start, we need to choose the regression line, which is the A plus BX. If it's not there, then you have to choose the regression equation. Then you're going to get 2 columns that are having X and Y, and sometimes even the frequency can be indicated. Don't worry about the frequency. So for the case of the X, we're going to enter all the top numbers. For the top row, all the numbers must be entered, and then the corresponding Y values should also be entered. Once that is done, we must press the AC button, or sometimes call it clear all. If not, you must use the on button, and just to clear whatever is in the calculator. Then from that, we're going to press Shift and 1. And then we choose the relevant item we're looking for. So in that case, we're going to start by looking for the value of A, and then the value of B, and rewrite our equation. Okay. So when I do that, enter my values, X and Y. Okay. I press the clear all button. And then once that is done, you can press the Shift and 1. And then I'm seeing my A as 1730.22. I'm getting a B of 13.96. Okay. So I want to use the answer book. Let's see if I can access it. Okay. So with this answer book, it's more or less the same information for the same table and everything. So we said Y must be the same as A plus BX. And we got our A as 1730.22. We say B was 13.96. So my equation is going to be 1730.22 plus 13.96 with X. Okay, so that is the regression equation. Then question number 2. They want us to predict the cells. When they talk of predicting cells, it's like we use the regression line because that line is used to predict what might happen in the future through extrapolation and interpolation. Okay, so we have 28,500 if this was spent on advertising, which means where there is X, we're going to replace with 28,500. Okay, so this is going to be what's happening here. Okay, so we said we're going to have Y is equal 1,730,22 plus 13,96 times 28,500. Okay, we just need to put this in the calculator once and for all. And then we're getting our Y value as a 399,590,22. So this is how much will be expected when this 28,500 is invested. Okay, then 1.1.3, write down the correlation coefficient of the data. So when you press the shift and 1, you go back to the steps that we got, and then you look for the R. And then you press the equal sign after pressing the R, or after pressing the number that corresponds with R, whether it's 1, 2, or 3, depending on the calculator type that you are using. So from my calculator, I'm getting R to be 0.98002, but 2 decimals, remember. So that's our R. And then they're asking us to describe the association between the amount spent on advertising and the sales. So when they talk of the association, they're asking for the relationship based on the correlation coefficient. Okay, so our correlation coefficient is a positive 0.98. So we're gonna say that the relationship is very strong, but also positive. Okay, I'm saying a very strong positive relationship. Sometimes we say correlation. Okay, so it's very strong because remember we have categories. When it's between 0.8 to 1, that is very strong. Between 0.6 and 8, 1 right. Okay, 0.8 to 1. I might categorize that as very strong, depending on the type of data. Sometimes you can start from 0.95 up to be high, to be very strong. And then for strong, it's between 0.6, maybe up to 0.79. Okay. Then moderate is between 0.4 to 0.59. And then weak can be 0.2 and so on and so forth. Okay. So that is that. Then the next question is asking us that if we have the profit that the small company made over the last, let's say, 9 years, as given in the table. Okay, so the first part is representing the regression data. Okay, and then the second part is representing more like a variable kind of data, where we have just one piece of data that is being get, which is just a profit. Okay, then they want us to calculate the mean. So this one, the same story. Just get your calculator into the mod format of the start. So press mod, okay, and then start, and then you can talk about the first set of data. Okay, so in this case, when I put my data, which is the single variable, I only have one column of X and maybe then the frequency. So ignore the frequency part, just enter these numbers into the calculator. So 110,750, 107, that, and so on and so forth. When you're done entering that data, with the frequencies, leave them as 1, 1, 1, not change anything. Then we're gonna press again, clear all of the on button. Then we're gonna press your shift 1 and then follow the steps again. Okay. So all I need is the mean. So the mean is usually represented by that symbol. Sometimes something like that in the calculator. So the mean I'm having is 172466.11. Okay. 1624. Oops. What's going on? Okay, so saying the mean is 172466.11 from the calculator. You get 2 marks for that. And then 1.2.2, they want us to get the standard deviation. Okay, that's what the question is asking for. Write down the standard deviation. So from the shift 1, we must look for the standard deviation. It's normally by number 3. Okay. So from my calculator, my standard deviation is 56950. Okay. Just gonna close this for now. Okay, so we got our mean. So we're saying we got our mean as and what was the value? It was 172466.11. And then we said the standard deviation is 56950.09. Okay, so these are the two answers for 1.2.1 and 1.2.2. Then 1.2.3, they want us to determine the number of years in which the company made a profit that was greater than 1 standard deviation above the mean. Okay, so when they talk of 1 standard deviation above the mean, it's the same as getting the mean plus 1 standard deviation. Now we know that our mean is 172466.11. I'm going to add the 56950.09. Okay. So when I do the maths, 172466.11 plus the 56950.09, I'm getting 22. Okay, 9416.20. Now the question is asking us, how many years did the company make profit that was greater than what we have? In other words, in how many years do we have profit that is greater than this? So go back to the data. Let me just make this a bit smaller. Oops. Smaller, so that I can see my data nicely. I think that's better. All right, so I need to look for amounts that are slightly bigger than 229. Okay, this is a no, this is a no, a no. 229, yes. No, yes. No, no, no. So which means we have just 2 years. So the company that much of profit for 2 years. That is the question. That's the answer from what was expected of us. Okay. That is 1.2.3. That's the whole of question on 12 marks. Then question number 2. Question number 2, please don't rush, don't rush. Okay. The ages of the people who attended the music concert were summarized. Okay, this is like group data. So these are the groups or the ages. But for ages between 15 and 5, we have 20 people. And then for ages between 25 and above 15, and then 25 and so on and so forth. So this is the information we have. Then the question is asking us to determine the modal class of the data. So mod, remember, modal comes from the word mod. And we know that mod is the data that appears the most. So when they talk of a modal class, they want us to get a class that is having the highest representation or the highest frequency, because now this is our frequency. So when I look at all this, I feel like 90 is the biggest representation. So we're going to have 35 is less x is less equal to a 45. And that would be our 2.1. Okay, then 2.2. They want us to get how many people attended the music concert. So all we need to do is just add up all those numbers. Okay. So I'm just gonna add up those numbers very fast. So we say this is 35 is less x less or equal to 45. So I'm gonna add that. So I have a 20 plus a 25 plus a 60 plus a 90 plus a 55 plus a 40 plus a 30. Okay. And the total that I'm ending up with is 320. So these are the number of people that attended that concert. All right, and then 2.3, they want us to draw a cumulative frequency graph. Sometimes we call this the OGI, okay, to represent the data. Okay, so one thing we need to know that as we are plotting the OGI or the OG, we need to know what we plot and what we don't plot. So since the grid just has everything that we need, we have the cumulative frequencies here, and then we have our edges this side. So these edges are more like the classes, but from the information, we don't have the cumulative frequency. So we need to create some sort of a color for the cumulative frequency. Okay? Because the cumulative frequency that we use when we are plotting a cumulative graph, we don't use the frequency. And how does the frequency of the cumulative go about? So the first frequency will represent the first cumulative frequency. And then for me to get the next cumulative, I'll just plus this 20 plus a 25. I'll get a 45. And then 45 plus 60, I'll get 105. And then 105 plus 90, I'm going to get 195. Then 195 plus 55, I'm going to get 250. 250 plus 40, I'm going to get 290. Then 290 plus 30, I'm going to get a 320. So the last cumulative must always correspond with the total number of participants or your total frequency, which is correct now. So when I'm plotting my cumulative, this 20, I'm going to plot it with a mean of 5. Okay. Then, no, that's not true. So I'm saying with the cumulative, I'm going to use the upper class boundaries. Okay. So I'm going to plot 75 with 320, plot 65 with 290, 55 with that, 45 and that, even this 15 must go with the 20. And then I'll just extend my graph to a 5. Okay. So what I'm going to do, remember we said we have a 20. Let me just put it somewhere. 20, 45, 105. Okay, so we know that the first one is 15, that goes with 20. Just okay, 15 is between 10 and 20, which is like halfway. 15 goes with 20. This is 1, 2, 3, 4, 5, which is 10, 10. So which means it's gonna be somewhere here. Okay, so this is the mark that I have. And then now I go to 25. 25 is gonna go with 45. Let me just make this a bit smaller so that I can see my values nice. So I got 45. So 25 is still in between here. I need a 45. That's a 40. So somewhere in the middle there. No, that's a 40, but it's close, slightly above. Okay. Then I'm going to 35. This is the line of 35. 35, where are you? You're going with 105. 35 with 105, this is 100. So somewhere, okay. And now I need 45. 45 is 195. So just before 200. Slightly before 200. Okay. And then I need 55 to say it's 250. 55 is 250. Just on the line here. Okay, and then we have 290. 265 is 290, just below 300. Okay, and then we have a 320. All right. Then we have a 320 for the last one, which is 75. This is 300, and this must be 320. Okay, so from that, I just need to connect. Okay. Connect that with your freehand. It might not look like an S curve for now. But remember, it's an algebra, so it has to just that something. And then remember, we said this must be connected to 5 and 0. So the starting point is 3. So just connect that to that. Okay, so that's going to represent my algebra. So this is the 5, which is the starting point of minimum transmitter. All right, that is what we had to do. Then they're asking us to use the graph to determine the median. All right, so with the median, since we have 320 people, some people prefer using a half of n plus 1 to get just the position. So that it is a half of 320 plus 1, and then they locate where that is. Okay. So what is a half of 320? Let me first use this approach. It's going to give me it's my graph for what, but let me just try to. Let me rejoin this line and see. I'm sorry, guys. It's live. I don't know. Something like that, guys. This must be slightly straight, but somewhere there. So I'm just gonna use a half of n. I can do the same with a half of 320, so it's 0.5 times 320 plus 1. That's going to give me 160.5. Okay. 160.5 is just the same as 160. So which means I locate 160 on this side. Okay. And then I must follow this line of 160 till I meet up with the graph. So it's where my graph is meeting. And then I'll drop this downwards. Find how many years it is. Okay. So this was 41, 2, 3, 4, 5. So which means every block is representing 2. So that's going to be like 42 years. Okay. So it's saying that's going to be 42 years just from the graph. Then question number 3. Question number 3. Let's make this a little bit smaller. Okay. So with question number 3, we're being told that in the diagram, the equation of AF is y is equal to negative x minus 11. Okay, this is the line AF. B is a point on the x-axis such that this B is a midpoint. The straight line joining A, which is down there. Okay. It's joining A and C. The angles of inclination are that, and the alpha, so angles of inclination are alpha, and then the 63,43 respectively. AF cuts. Where is AF? Okay, it cuts the x-axis at B, and then D is a point such that DE, okay, this line is parallel to AC. And that one parallel. Okay, so that is all the information we have. First question, they want us to get the value of T. So where is T? T is by point A. Okay. But then since we have the equation of the line onto which T is released, whatever put, we can just substitute this point into the equation of the line. Because if a point is lying on the line, that point must satisfy that equation. So we're going to have y is equal to negative x minus 11. What is the x coordinate? The x is negative 1. So I'm going to say y is equal to negative 1 minus 11. The answer is negative 10. Okay. So which means my t is negative 10. Then they want me to get the size of alpha. So for me to get alpha, remember alpha is an angle of inclination. From our earlier grades, we say that if you have m, it must be equal to the tan of, let's say, alpha. But the gradient must be equal to the tan of the angle of inclination. So the question wants the value of alpha. So for us to get the angle, we must get the shift tan, the arctan of the gradient. So we need to know what is the gradient of this line. From the equation, y is equal to mx plus c. This is y is equal to negative x minus 11. So our gradient is a negative 1. Okay. So I'm just going to replace that with a negative 1. But since I'm going to end up with a negative answer, because I know that the shift tan of the negative 1 must give me a negative answer, I need to plus 1 so that I end up with a positive answer. Okay. So I'll say shift tan of negative 1 is negative 45. So the negative 45 is just representing this. Negative, but that is a 45 down there. And then since angles are on a line, angles on a straight line, I must just plus 180 or subtract from 180. And then I get the answer. So that's negative 45 plus 180, then I get 135 degrees. So that is my alpha. Then 3.1.3, they want the gradient of AC to the nearest whole number. So AC is this line. Okay. But all we know about this line is just one coordinate, which is E. So we don't have any other coordinate points that we have. So we cannot use the normal change in Y over change in X. But all we have is the inclination angle. So we're gonna say that the gradient must be equal to the tan of the inclination, which is 63.43. Okay. When I use this, I'm getting 1,999,568 and so on. But they told us we must round it off to the nearest number, nearest integer. Okay, so that is a 2. And then we're done. Then 3.2, they're asking us to get now the equation of AC. Now, since we already have the gradient, and there's this one point A, we can use that. So we're going to use the gradient of 2 and point A, which is -1 and -10. Remember correctly, yes. So there are two ways of doing this. Some people prefer using the mx plus c format, where they substitute the m and these points and get the value of c. So let's see. So where there is x, I'm going to put a -1. Where there is y, I'm going to replace with -10. So -10 is equal to m, which is a 2 times -1 plus a c. Then I'll move this to that side. Okay. So that's going to be -10 plus 2 is equal to c. So my c is -8. And that is done. I just rewrite it as 2x minus 8. Okay. Alternatively, someone can use y minus y1 is equal to m into x minus x1. So still the same thing. That is y1 and x1. I'll replace these coordinates. It will be y minus -10 is equal to 2 into x minus -1. This is y plus 10. When I open that, I have 2x plus a 2. Then I'll move the 10 that side. It's going to be 2x plus 2 minus 10. So that y is 2x minus 8. So it's just the same equation, but different formats. So you choose whatever will work for you. And then 3.3.1. Okay. So 3.3.1, they want us to get the coordinates of C. Now, since we have the equation, for us to get the coordinates of C, we need to know the coordinates of B first. Then we can apply our midpoint formula. So what I'm going to do, I need to get the coordinates of B. Okay, so I'm saying the coordinates of B. From my equation, y is equal to 2x minus 8. We know that at B, y is 0. Okay, let's just replace y with a 0 and look for the value of x, since B is on the x-axis. So 0 is equal to 2x minus 8. Can move the 2x that side. -2x is equal to -8. And then I'll divide by -2, so which means my x is a 4. So the coordinates of B are 4 and 0. Then from the midpoint, which I know that x1 plus x2 over 2 must give me the midpoint. Then y1 plus y2 over 2 must give me the y coordinate of the turning pole of the midpoint. So if I call the coordinates of C to be x and y, okay, so I'm going to combine this x and this -1. I combine the two of them so that I can get my 4. The x and this -1 must give me a 4. It's the midpoint. And then this y and the t, which was a -10, combined using the midpoint, and must get to 0. All right. So we say if I get my x plus my -1 over 2, I must end up with a 4. And then I cross multiply with this. So I'm going to have x minus 1 is equal to 8. Then I'll move the 1 that side. X is a 9. Then do the same thing if I have y plus a -10 over 2. Must give me 0. Cross multiply. So y minus 10 is going to be 0 because 2 times 0 is 0. Then I'll transpose the 10 that side, so which means y is a 10. So the coordinates of C are just 9 and 10. All right, then 3.3.2, they want the size of FED. What is FED? FED. So they want us to find this big angle. This angle. All right, so what I can do, it's a two-way thing. If I call this maybe M, just I know that this angle is 63.4, that even this angle here is going to be 63.43. So if that is 63.43, which makes this angle alone, our bottom also be 63.43. Okay, because they are corresponding angles. Remember, these lines are parallel, so those angles will be corresponding. And then since our alpha was 135, which means this remaining patch is going to be a 45 degrees, and then I can plus the 2. So I'm going to say MED. Or if not, I can start with OBA. Okay. I'll start by saying that OBA, OBA is 45 degrees because those are vertically opposite angles. Okay. And then remember we've created M, so it's going to be MED. So MED is also going to be 45 degrees because those are corresponding angles. For which lines? DE and AC. DE is parallel to AC. Then I can say that MEF, 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 what am I doing? What am I doing? There's something wrong here. I just have to restart afresh. Not the 45 days. 63.43. 63.43. 63.43. So this is the 45, which will be angles on a straight line. Okay. Then now I can have my FED to be the sum of 45 plus the 63.43. Okay. So that's going to give me 108.43 degrees. Then 3.4. J is a point such that EAGC, EAGC is a parallelogram. So if EAGC is a parallelogram, which means EG must be a diagonal. Okay. So if I connect this, do that. Please do that. Okay. What do they want me to do? Question, what are you asking for? You want the equation of a circle that is centered at G and passing through B. So which means I need to find the coordinates of G. That's what they're indirectly asking for. But one thing we know about a parallelogram is that the diagonals do bisect each other, which means the distance from A to B must be the same distance from B to G. So which means B is still a midpoint. Okay. So what we don't know are the coordinates of E. If we can get the coordinates of E, then we can get the coordinates of G. Okay. So I'm going to say from y is equal to negative x minus 11. We know that at E, y is also 0. So where there is E, I'm going to put a 0 where there is y. Okay. So 0 is equal to negative x minus 11. Move the x that side, which means x is 11. So the coordinates of E, it's a negative, not a positive. The coordinates of E are negative 11 and 0. Then from the midpoint, remember x1 and x2. So I'm going to call this x1 and y1. Then combine it with the coordinates of G, which are negative 11 and 0. Combine them, and must get the 4 and 0. So I'm going to have x plus the negative 11 over 2, and it's giving me 4. Okay, I'll cross multiply that. So x minus 11 is 4 times 8. So 4 times 2 is 8. I'll move the 11 that side. I have 8 plus 11, which is a 19. Then do the same thing with the y. So y plus, but why should I even stress with y since y is on the same line? Okay, so y is 0. So therefore the coordinates of G are 19 and 0. Okay, it's the same horizontal line. Since E, G must be diagonal, which is the x-axis. Then, since I want the equation of a circle, this distance BG is going to represent my radius. So I need to get the distance of BG, but since it's the same horizontal line, I'm just going to subtract what is 19 minus 4, which makes it 15. So my radius is 19 minus 4, which is 4. So for as long as the distances are either on the x-axis or the y-axis, we don't need to use the distance formula. Just subtract those values. For as long as the y values or the x values are the same, just subtract the big one and the small one. Okay, so from the equation of the circle, y minus a squared plus this must be equal to r squared. So x minus a squared. And so I'll substitute that's going to be x minus 19 squared plus, I know y minus 0 is y, so that's y squared is equal to my radius 15 squared. That's going to be 225. All right, question number 4. Question number 4. Question number 4. I'm telling us that in the diagram, the equation of the circle at M with these center coordinates is given as this. And the equation of the center at M is given as that. Okay. Then P, R, and PS are tangents to the circle M. PR is parallel. PR is parallel to the x-axis. And then we have coordinates of K, which is negative 17 and negative 5. The straight line N cuts this minor circle at T. And then the larger circle at S. All right. Then the first question is asking us to write down the coordinates of M. Do we have the equation of circle M? The answer is yes. Because remember that equation is x plus 6 squared, then y plus 3 squared, then 5. So remember what we say, we always just get these coordinates but switch the signs. Okay, so M is going to be negative 6. Negative 6 and negative 3. There we go. Then they want us to get the length of the radius of the smaller circle. Now, from the equation, okay, so we have x squared, so we say negative 6 and negative 3. So from the equation, which is x squared plus y squared 24x plus y squared plus 24x minus 25 minus 10y plus 153 must be equal to 0 plus 24x. Okay, there we go. So for us to get the radius, we need to complete the squares. Remember what we said. You can do the grouping if you want. The x and y and y. So I'm going to say x squared plus the 24x. And then I'm going to have y squared minus the 10y. I'm going to take this side, which is negative 153. Then when I complete my squares, remember we said it's x, and then the sign, which is a plus. And then we have this. A half of 24 is 12, and then you square that. So we know that a half of 24 is 12. When you square 12, you're going to get 144. So which means on our right-hand side, we plus the 144. And then we do the same thing with the y. This is y. The sign is negative. A half of 10 is a 5. We know that negative 5 or positive 5 squared must give us a 25. So I'm going to plus the 25 inside. And this is going to be x plus 12 squared plus this is y minus 5 squared is equal to, I simplify my right hand side, I have negative 153 plus 144 plus 25, 16. Now remember, from the general equation of this circle, this is y minus b squared is equal to r squared. So this 16 is representing r squared. So we need to find the square root of 16, which means our r is 4 units. Okay, r becomes 4 units. That's from there up to there. All right, that is done. Then the next question is asking for the length TS. TS. So the distance between T and S. All right, so do we know the radius of the big circle? Yes. Okay, so the radius of what is the distance SM? So I'm going to say the distance SM is going to be the square root of 25, which is 5 units. Okay. We say the distance of NT, we found it to be 4 units. Then all I need to find is the distance NN. Then I'll subtract these two. So NM from the distance formula, we say x minus x1 squared, and then y minus y1 squared. And I try to substitute that. Remember, I have negative 6, negative 3. And I have negative 12. The square root. I'm going to have negative 12 minus 6 squared plus It's a 5 minus 3 squared. Can put this in brackets, please. Then when I punch that into my calculator, I'm getting the square root of 56 plus 64, and then that is giving me 10. Okay. So that 10 is representing the total distance from N to M. But we say this is a 5, and then this is a 4. So what is left here? It's going to be 1 unit. So 10 minus 5 minus 4, which is 1 unit. So therefore, ST, is that what we are calling it? Yes. So ST is 1 unit. Then 4.3. 4.3. Determine the equation of the tangent PR. PR. We want the equation of this line. What do we do? What do we do? Should this be negative 3? So we know that this line is parallel to the x-axis, and we know that the x-axis is in the form of y is equal to 0. So which means all horizontal lines must be in the form of y is equal to something. But we need to find out how low is point R. Since we say this is 5 units, even that will be 5 units. Already I have the same circle. Yes. So I'll start by saying that my MR is 5 units. Okay. Just the distance from M to R. And for me to get the total distance from the x-axis to R, I'm just gonna take this negative 3 and 5. Okay, so I'll say if I have my 5 minus 3, that's gonna give me 8 units, which means from here up to R, those are 8 units. They are down. So it's like negative 3 minus 5 must give me negative 8. Negative 3 minus 5, we're saying negative 8. So y becomes negative 8. That is the equation of that tangent. Okay. And then the next question wants us to get PS. Okay, what is PS? The equation of PS in the form of mx plus c. PS in the form of mx plus c. So do we know the gradient? No, we don't know the gradient, but we have one coordinate point, which is fine. We can get the gradient from mn, since it's a straight line, and so I'll start by finding the gradient of mn. Okay. So gradient of mn is going to be changing y over changing x. Okay. Then I'm going to have 5 minus 3, okay, over negative 12 minus 6. Simplify that, that's going to be 8 over negative 6. And that's giving me very negative. Yeah? But one thing I know is that this is more like a radius. Let's say ms is a radius. But we know that the radius and the tangent will be perpendicular. So from my m1 times m2 being equal to negative 1, the condition for perpendicular lines. So if one line is negative 4/3, I'm just going to flip that and say that the gradient of PS is going to be 3/4 positive. Since it's negative, it must be. So what I'm doing is I'm dividing -1 by -4 to make online the subject. Now, since I have my gradient, there's a point K. This point K is -17 and -5. So I'm going to use that. I can use the proposed formula of y is equal to mx plus c. Okay. And then I look for the values. So this is my x, that's my y. So -5 is equal to 3/4 times my x, which is -17 plus c. This is -5. When I simplify that, I'm getting -51/4 plus c. Then I'll move this -51 to that side to make c the subject. So it's -5 plus 51/4. That's going to give me positive 31/4. That's my c. So which means my y is going to be 3/4x plus 31/4. Bingo, done. Then 4.4. They're telling us that the quadrilateral PSMR, this is interesting, let's see, PSMR, okay, this is the quadrilateral that they're focusing on. Then they want us to find, is it the perimeter? It's the perimeter of PSMR. So one thing we know is that perimeter is the total distance around the shape, but we know that PM, PS is going to be the same as PR because this is a tangent and this one is also a tangent. So tangents from a common point must be the same. We also know that MR is the same as SM. That is, they have the same circle. So we already have this and that. All we need is this distance. One of them. Either we get the distance PS or we get the distance P. What are you going to do? So since I have the equation of this line, we say 3/4x plus 31/4. Then I have this equation. I can get the coordinates of this. Okay, and then I'll know that my coordinates of R are -6 and -8. By draw straight line. It's going to be the coordinates. So if I can get the coordinates of P, then I can use my distance formula to, I wouldn't even need a distance formula since I'm going to have the same -8 somewhere here. I can get this -8, substitute it into this equation by the y, and then I equals done. I'll get my P, get the distance, and then I'm ready to go. All right, so I'm going to say that at P, y is -8. Then I'm going to substitute this there and say that -8 is equal to 3/4x plus 31/4. I am seeing that I have a denominator of 4. I can multiply through by 4. So times 4 times 4 times 4. This cancels that, cancels that. Then I'll have a -32 is equal to 3x plus 31. When I move this that side, we'll have a 63 negative is equal to 3x. And then I can divide both sides by 3. Okay, so which means my x is going to be -21. So the coordinates of P are -21, -8. The coordinates of R, remember we say -6 and -8. Okay. Then for us to get the distance between these two, since the y values are the same, let's just focus on this. Get the bigger value, -6, minus the smaller value. Okay. When I do that, I'm getting 15. Are you sure? Are you for real? Yeah, 15 minutes. Okay, then perimeter. So remember, if I get my perimeter, the conditions will say PS is the same as PR. PS is the same as PR. Reason, the tangents of common point. Okay, then we said MS and MR. MS is the same as MR, that is radii, okay? So which means our perimeter is going to be 5 plus 5 plus 15 plus another 15. That's 40. I'm getting 40 units. There we go. Then 4.2, we want us to get the ratio. We can get the area of NPS over the area of the entire quadrilateral. NPS. Just change this to big things. So if we draw something for this area here. But one thing we know, this was a 90, no? The tan radius. So even this must be a 90. So that's the right angle triangle. We know this is a 4. This small distance here is a 1. So which means that total distance there is going to be 5 units. We've assumed this to be 15, since we said this is the same as that. So we can get the area of that. Then they want us to get the area of this entire quadrilateral. I'm gonna split this quadrilateral into 2 also. Since I don't know what type of quadrilateral it is, but I can see right angles. That's a 90. That's also 90. So it's literally going to have the same area. So 15 and 5. All right, so what I'm gonna say, area of NPS. Area of NPS is gonna be a half base height. And that's it over the area of the quad, which is also 2 times a half. Also gonna say times half base height. Let me call this height 1. It's the same base, not a problem. So that's gonna be a half times our base. We said it's 15. Okay. Our height was a combination of 4 plus 1. Then over, this is 2 times a half. Okay. Our base is also 15. This 15 and the 15. Height is 5. So why am I saying 2? Because we have 2 of them. This is number 1. This is number 2. When I combine them, I have the entire area of the whole shape. Okay, so this 15 is going to cancel that 15. This half is going to cancel that half. 4 plus 1 is 5. And then this 5 will cancel. So which means I'm getting a half as my ratio. Okay. That was pretty good. All right. Let's move on. Question number 5, which is trade. Trade, here we come. All right, so with question number 5, they are telling us without using a calculator. Now we don't need to use a calculator in this. We just need to follow our identities. Okay, remember they want you to express this into a single trig ratio. So follow the identities of the reduction and all of that. Okay. So I have 1 minus sine negative theta cos 90 plus and cos theta minus 360. What do I see? Okay, so I can see some element of complementary angles. I can see a reduction part. given this. So if I can play around with that, then I'm good to go. Okay, step number 1. What I'm going to do, remember it is 1 minus sine of negative theta, cos of 90 plus theta. I'm dividing it by the cos of theta minus 360. Okay, so that's 1 minus the sine of the negative angle is the same as you put in the negative outside, so that's what means the positive angle. I'm multiplying by the cos of 90 plus must give us a negative sine of the angle. You can open this using compound angles, but we know from our reduction of complementary angles that cos must give you sine and sine must give you cosine. Then down here, the cos of theta minus 360, this does not matter for as long as it is cos. It only matters when it's a sine or a tan. Okay? Because someone will say, let's first factorize out the negative. Okay, we can do that. It's a negative so that we have a normal representation of the reduction. But we know that the cos of the negative angle is the same as the cos of the positive angle. That's why we said this doesn't really matter, but it's okay. Simplify that, we're going to have 1 plus the sine of theta multiplying by negative sine theta over 360 minus is in quadrant from your cast down. Okay, this is 180 minus theta, 180 plus theta. This is 360 minus theta, and then this is 360 plus. Okay, so we're going to find it in the 4th quadrant. In the 4th quadrant, cos is positive, so that's going to be the same as cos of theta. Okay, this negative is going to affect that, so this is going to become, let me just write it here, it's going to be 1 minus sine squared theta over cos theta. Then from our formula sheet, we know that 1 minus sine squared gives us cos squared theta over cos theta. Then we can just reduce that to just a cos. There we go. All right. So that is done, that is done, that is done. 5.2.1 for 2 marks. Telling us if you've been given cos 20 to be a p, calculate without, you don't need a calculator for each of the following in terms of p. So in terms of p simply means our answer must have a p attached, okay? And then with these angles, we always need to find a way of expressing them with either 20 or a multiple of 20 at most. Okay, so the first kind of scenario we need to do, come up with a sketch. Okay, whether you're going to need it or not, just come up with a sketch. In most cases, we need it. Okay, so that is a 20. And then they told us the cos of 20 is p. So this is the same as p over 1. Okay, there's nothing at the bottom. So cos is adjacent over the hypotenuse. So this is a p, this is a 1. And then from our theorem of Pythagoras, we need to find the missing side here. This is going to be 1 minus p squared. Okay, if you get x squared plus y squared must be equal to r squared. So our r is a 1. Our x is a p. And then our y is what we're looking for. Move this that side, you get 1 minus p squared, and then find the square root on either side. There we go. So this is done. Okay, but they want us to get a cos of 200. Then cos 200, how or which numbers do we play with so that there's a 20 involved? We can either reduce, because we can't get 100 from a triangle, remember, just introduce it to an acute angle. So looking at this, I can say cos of 180 plus 20. That gives me 200. So I must get the same result, but represented in a format that I can reduce. So 180 plus, that is quadrant number 3. And in quadrant number 3, cos is negative. Okay. So this is going to reduce to a negative cos of 20. Question told me cos of 20 is P. What about the negative cos of 20? So that's going to be a negative P. And then we're done. Then 5.2.2, the sine of negative 70. Okay. So remember, if you have a negative angle, first move the negative outside. So negative sine of 70. Then the question is, which number do I play with to give me 70? But that number must have a 20 attached. So I can use 90 minus 20. Okay. If I use 90 minus 20, this is still complementary. So it's going to be negative, but with a cos of 20. Okay. Then still, which is the same as the previous question, which means our answer is a negative P. Then 5.2.3, they want the sine of 10. Sine of 10. So now, what is happening? We have a 20 and then we have a 10. So you can see that 10 is just a half of 20. Okay. So what I'm going to do, I can try to use the, I don't know, what can I use? The double angles. Is that going to make sense? Yes, it can make sense. Let's say I have cos of 20. And then I have to reduce this. Know that cos of 20, but let me just say that 20 is the same as 2 times 10. Okay, I just want to look at cos 2 times 10 of the cos. Okay, the double angle of cos. So this can be given as 2. Should I use cos? Should I use sine? It's fine. I'll say 2 cos squared 10 minus 1. I can just use the sine because I know it is going to be cos squared of minus sine, which is 1 minus 2 sine squared of 10. Just take this out, this goes. I'm going to say 1 minus 2 sine squared of 10. Okay, so I have my sine 10 represented. I'm still having my cos 20 beside. If I try to make sine 10 the subject, let me just switch this so that I have 2 sine squared 10 is equal to 1 minus cos, say 20, because 2 times 10 is 20. Okay. Then I'll divide both sides by 2, so sine squared 10 is equal to 1 minus cos of 20 divided by 2. Then I can take square roots on either side to eliminate that. So that my sine 10 is going to be the square root of 1 minus cos of 20 over 2. Okay. But whenever I find the square root, I can have a plus or minus, but that's not a big deal. Okay. Then I can now do the substitution. What was the question saying? The question was talking about the cos of what? The cos. Was it sine or cos? Question, what did you give us? Give us cos of 20. Is the same as the P. Okay, so when I do my substitution, I'm having plus minus the square root of 1 minus P over 2. That's my answer. That is the sine of 10. All right, then 5.3. Determine without using a calculator the value of this. So this is a cos A plus 55, A plus 10. So it's a cos, and then plus a sine. So if I hold the whole of this to be my A and the whole of this to be my B, this is a compound angle kind of question. Okay. So we have a cos. Okay, so we have the cos of A plus 55, and then the cos of A plus 10. Okay. Then we're saying plus the sine of A plus 55 times the sine of A plus 10. So from the the compound formula, I can see that we are combining just cos. So if that is my A and that is my B, so if I have the cos of A minus B, that's when I can expand this whole kind of thing. I have cos plus, then this minus in between. So I'm going to have cos, this is A plus 55 minus the A plus 10. Okay, so that's a cos of A plus 55 minus A minus 10. So that reduces to a cos of 45. And then from our special triangles, that is a 45, that's a 45. So 1 and the 1 and the root 2. So cos of 45 is just the same as 1 over root 2. Okay, and then 5.4.2, no, 5.4. 5.4.1. Okay, they want us to prove the identity. Prove the identity. So with proving, we have the question and we also have the answer at the same time. So that's a cos 2x. Are you sure, Maluma? Yes. Plus sine 2x. Okay. We are subtracting cos squared x. And then we are dividing this whole thing by sine x minus 2 cos x. They're telling us this must reduce negative sine x. Okay, so one thing you need to know is that when you're proving, you need to start from one side so that you get to the other side. And if that is being done, do not involve both parts into your proof. Just work with one and then you end up with the other. So I'll say that I'm starting from the left-hand side. Okay, I'm seeing the double angle cos, the double angle sine. And then on my right-hand side, I'm only having sine x. All right, what am I going to do? Let me change this. I'm going to change everything to a sine, if possible. Okay, so I'll break down the cos 2x into something like 1 minus 2 sine squared x. Okay. 1 minus 2 sine squared x. Plus the sine 2x is going to be 2 sine x cos x minus this is cos squared x. This is over the sine x minus 2 cos x. Okay, when I change that, okay, what next? What do I see? Is there anything that I can combine? Yes, I can combine this. And that. If not, I can change this to 1 minus sine. 1 minus 2 sine squared x plus 2 sine x cos x. Then I'm going to have 1 minus, so negative 1 minus sine squared x, which is going to give me negative 1, then plus sine squared x. Write on this by the sine x minus 2 cos x. So is there anything that is common for me? So this is going to cancel that. This is going to reduce that. So I'm going to have negative sine squared x plus 2 sine x cos x over the sine of x minus 2 cos x. What is common there? You can see there's a sine x and there's a sine x. Check out the negative part of it. Okay. I'm going to take negative sine x outside. I'll be left with just a positive sine x minus this and that, 2 cos x. I'm dividing it by sine x minus 2 cos x. Okay, so this and that will cancel. I'm left with just negative sine x, negative sine x. Okay, so which means my left hand side is equal to my right hand side. Okay, so that is that. Did I? Okay. 5.4.2. They want us to determine the value of this working. Okay, so when I look at this, does it look like the top part, this, and that? Okay. And then I'm seeing the bottom part, there's a sine squared. And then there's a cos, which means there's an introduction of something extra here. Okay, let me see if I can break this down into my original equation. Okay, so I have the same top things, which is cos 2x plus sine 2x minus cos squared x. And then we're dividing it by, remember it was negative 3 sine squared x plus a 6 sine x is that true? Plus x. Okay, so let me try to create the original. So I'm going to have cos 2x plus the sine 2x. I'm not going to expand anything. I'm just going to reduce it. So we are saying something extra was added here. So I'm going to take that extra. Since there was a 2 here, and there was nothing here, I'm going to take whatever is in front of it, which is a 3. So negative 3 must come out, but it must be a negative 3 sine. So since I'm seeing an extra sign, okay, so I'll be left with just one single sign. This is going to reduce to a negative. 3 is out, so it's a 2 plus x. Okay, so this whole thing just looks like my original expression. Remember, this whole thing was the same as negative sine x. Okay, so I can replace this whole thing by sine x and then I multiply by that. So that's going to be negative sine x times 1 over negative 3 sine x. So this sine x is going to cancel that sine x, negative and negative, and I'm going to have just 1 over 3 as my answer. Okay, and then 5.5.1. If you're given 3 tan 4x is equal to negative 2 cos 4x, without using a calculator, can you show that this is the only solution? It's a sine. You don't have anything like tan. Okay. So 3 tan x, no, 3 tan 4x is equal to negative 2 cos 4x. Okay, I'm going to change this from that identity. Okay, I'll say 3 sine 4x over cos 4x is equal to negative 2 cos 4x. I can solve for 1. And then I'll do my cross multiplication. I have 3 sine 4x is equal to negative 2 cos squared 4x. 2 And then I can change this to a sine. I have 3 sine 4x is equal to -2 into 1 minus sine squared 4x. Then I'll open that up. I have a -2, negative and negative. I have a +2 sine squared 4x. I'll move this that side so that I have 2 sine squared 4x minus 3 sine 4x minus 2 is equal to 0. Okay, I'll try to factorize this. I open my 2 brackets. Let me just change the color. Okay, there's a 2 there, so it means I'm gonna have a 2 sine x and maybe a sine x there. Which numbers do I multiply to give me -2? It has to be a 2 and a 1. Okay, the signs, one must be positive, one must be negative. We make this a negative and a positive. That is 2 sine squared. This is -4 plus 1. Okay, that's fine. So from my dot product, this sine x is going to give me -1/2. Or sine x must give me a 2. But when you're finding solutions, remember the angle or the result of sine must always be between 1 and -1. It cannot exceed that. So since this is exceeding 2, we don't have anything like sine x is equal to 2. So this is not applicable, but this will give us the solution. When you draw your conclusion that therefore the sine x is equal to -1/2 is the only solution. Remember, -1/2 is the same as -0.5. Then 5.5.2. Hence, determine the general solution. So general solution, since I've told us this is the only solution, we only need to get what we call the reference angle. Okay, if we get the reference angle, then we're good to go. So our sign is negative, né? So we're gonna look at quadrant number 3 and then quadrant number 4, because those are the only quadrants where sign is negative. Then for me to get my reference angle, I need to say x is the shift of half, which is going to get it. Just ignore the negative. That negative is used to identify the quadrants. And then in quadrant number 3, okay, my x is going to be equal to, remember in quadrant 3, that's where we have 180 plus. I'll just write everything there. So it's 180 plus 30 plus sine, which is 360 times k. Remember, sine and cos is a period of 360. It's only tan that uses 180. Yeah? All right. So, sorry, something is amiss. Something's amiss. This is meant to be 4x. Even here. So 4x. That 4x. Okay, so which means that is still our 4x. Please do not divide the 4 and the that as yet. So which means our 4x is going to be 210 plus 360 times k. We divide through by 4, we get x alone. What is 210 divided by 4? That's 52.5. Plus 360 times, oh, even 360 must be divided by 4. What's wrong with me? So that's going to be a 90 times k. K is an element of integers. So if it's a division or a multiplication, it affects everything. But if it's just addition or subtraction, it affects just the angle and everything of the left-hand side. That is quadrant number 3. Then in quadrant number 4, I'll still have my 4x is equal to 360 minus 30 plus 360 times k. Remember, the quadrant 4 is represented with an angle. Then 360 minus 30 is 330. I'll divide by 4. Okay. 330 divided by 4 plus a 90 times K. 330 divide by 4, getting 82.5 plus a 90 times K. K is an element of integers. Okay, so an element of integer simply means you can just replace K with the normal integers of negatives, positives, as well as the zero to get our solutions. Okay, so guys, that is that. Question 5. Question number 6. Okay. Question 6, they are telling us that in the diagram we have these graphs, but we're only focusing on negative what? Negative 90 and positive 180. And that's our domain. K, we have f of x, which is tan of x minus 45. So this negative simply means the graph is shifted, because this is a phase shift. Shifted 45 units to the right, so which means it was meant to be somewhere here, but it's been shifted to somewhere there, 45 minutes. Same applies with all these terms. Nevertheless, they want the period of f. So when you talk of period, it's like after how many intervals do we see the full graph? Okay, so this and that becomes the full graph from here up to, since we have that and then this bottom part. Then we have that and then this bottom part. So these are two graphs of time. So our period, since there is nothing in front of x, the period is just going to be 180 degrees. Okay, so that is 180 degrees. Then they want us to draw negative cos 2x between the same interval. Show all the intercepts with the axis and the minimum, maximum time points. So from your calculators, no? Remember, we got mod and then the table, get f of x, then we're gonna put negative cos 2 alpha and x, close the brackets. We don't have a g, so we can ignore that and just press equals. We're starting from negative 90. We are ending at positive 180. Our steps, are using the steps of 45. Then we have our table. Okay, so remember we said mod, go for the table, and then from the table you enter the function f of x, which is negative cos 2x. No, it's negative cos, not negative. Okay, then I'm gonna give you the starting point. Start is where the domain starts, which is negative 90. And then the end, I'm gonna use 180. And then for the steps, these are the intervals from 0 to 45, according to the grid that we've been given. Okay, that's a 45, and then we sketch. So from what I have, I'm having negative 90 with a 1. Okay, just remove this. And then negative 45 is a 0. 0 is a negative 1. 45 is a 0. Then I'm having 90 to be 1. And then 135 to be 0. And then 180 to be negative 1. Guys, remember, this is a graph, not a line. So in as much as the points may not really be sufficient, just try to make sure that this looks like a curve. Okay, some people will force a line out of this. use that. It's a graph that you join using free hands. I may not be that accurate, but I'll try, okay? So we have something like that. It's gonna turn something like that. Okay, so that is my graph of, we call it G. Okay, done. Then they want us to write the range. Remember, range represents the y values. So according to the graph, I can see that the minimum point it can go to is -1. And the maximum that it can reach is a +1. So I'm going to say -1 is less or equal to, less or equal to +1 because it is passing through -1 and +1. So I must use the equal sign as well. Then 6.4, the graph is shifted 45 units, the graph of G, to the left. From the graph of what? H. Can we determine the equation of H in the simplest form? So when you shift something 45 to the left, it must be represented with a plus sign in that format. So where there is x, remember it was negative cos 2x. No? So where there is x, I'm going to represent with that shift. So x plus 45. I'll open that up. I'll have 2x plus a 19. Okay, when I simplify this, remember it's a complementary angle. I have a cos of 90 plus. That's going to give me a negative sign. So negative and negative sine 2x is going to give me a positive sign 2x. So which means my h of x will be given as that. Okay. Then 6.5, please the graph determine the values of x for which. So using the intervals of -90 and +90 only. -90 and +90. Not 180. Okay, so for which we want f of x to be greater than 1. So where do we find the graph of f to be above 1? Okay, so we can see that this area, the graph is above 1. What are the values of x between this and that? And then above 1, at this point it's at 1, but we said our end point is 90. We can't go beyond that. So for f of x to be above 1, I'm just going to say -90 and then. So my answer is going to be -90 is less or equal to x and less than 45. Since the graph is not touching the line of 45, so I'm not with the equal sign, but it's passing through the 90. Then the next point, next question, 6.5.2. They're telling us that if we have 2 cos 2x minus 1 is greater than 1, for which values of x is that? So what I'm going to do, I'm going to try to work around this and create this original. And this is a 0. So I'll start by moving the one to that side. So say 2 cos 2x minus 1. This is greater than 0. Move the one that side so that you have 2 cos 2x is greater than a +1. Then I'll divide both sides by 2 so that cos 2x is greater than a half. Then when I multiply through by a negative or divide through by a negative, this inequality symbol changes. So that's negative cos 2x will be less than the half. So which means the question is asking me for the values of x for which g of x, okay, is less than negative a half. Okay, so from the graph of g, just go back. If I have this as my a half, the negative, I want these values here. Okay, these values here. Only those ones, because those are the only values where this graph is going to be below zero, sorry, below negative a half. And remember, they told us between negative 9 and positive 9. So we cannot include the issues of this part. So our focus is just that area. So from our trig, we know, okay, that if we were to look at the arc side of a half, remember we're not meant to use calculators. That's going to give us a 60. Positive or negative doesn't matter. When you divide by 2, that's when you get a 30. So I'm going to say negative 30 is less x. That's equal to positive 30. For which values? They say greater. Okay, if it's greater, and now we found less, I don't need to put the equal signs, you know. That's wrong with me. Yeah, negative 30 less or equal to 30. The previous question, they said greater than 1. So which means there's no need for the equal sign. All right. That is question number 6, guys. Let's go to question number 7, which is the application of trig. Question number 7. So in this question, at least we need to know about the area rule. Okay. We must know about the sine rule and then the cosine rule. Those are the 3 that govern this question. If you know that and not play around with it, then you good to go. Then question 7, they are telling us the diagram A, B, C are points in the same horizontal plane. So horizontal is like just the same flat surface. That's a plane on its own. D is a point such that it's above C, in that DC makes a 90 degree with AC, and the same with EC. It's given that our ACB is 100, CAD is 30, AD is 20, and then BC is 18. So everything is indicated for us. Okay. Then they want us to get the length of AC. Where is AC? This is AC. Now this AC is surrounded by 2 triangles. We have this bottom triangle, this angle. Now I see that the triangle with more information is the ACD. It's a 90, so I can use that. So I'm going to say from ACD, okay, from triangle ACD, I can use the trig ratios now. Because I need this, I have that. So this is our hypotenuse, this is our adjacent. I can use the cos. So we're saying the cos of 30 must be equal to the adjacent, which is AC over 20. When you cross multiply, that's going to be 20, the cos of 30, and that's going to give me 10 root 3. I can write it as 17.1. They tell us about meters. Just call it units. So I'm going to just stick with the 17.32. When 7.1.2, they want the distance AB. This is AB. Okay, so with AB, this is 17.32. For me to get my AB, then I need to use the bottom triangle. And which rule am I going to use? Let me use the cosine rule since I have two sides. Okay. So I'm going to say that AB squared is going to be the same as AC squared plus BC squared minus twice AC times BC, the cos of BCA or ACB. Then my AB is going to be the square root when substitute. AC will get 17 squared. This is 8 minus 2 times 17.32 times 8. And it's over 100. I'll put this into the calculator straight out. 20.30. 20.30. Okay, now 7.2. If it's further given that ABD, so all of this is 73.4. And we find the angle AD. Wait, that's not true. That is what we want. Okay, we've been given AD, ABD, all of this to be 73.4. So this angle goes with that. This angle can go with that. Remember this second one. So which means we can use the sine rule. Okay. So from our sine rule, which triangle are we using? The triangle ABD. ABD. We're going to say, since we're looking for an angle, I'll start with the angles. Sine of D over AB. Sine of D over AB must be equal to the sine of D over sine of D over the distance, which is AD. Then I'll do my substitution. Okay, so that is the sine of D, which is like ADB over our AB that we got as 20.30. Must be equal to the sine of the angle that we're given, which is 73.4 over the distance, which is a 20. I'll cross multiply. So it means the sine of ADB is 20.4. The sine of 73.4 over 20. Let's simplify that. Sine of ADB is giving me 0.9727, and I must find the shift sine of that. I'm having 76.58 degrees. All right, question number 8. Euclidean geometry. Okay. With question number 8, they're telling us that in the diagram, O is the center. KTL points, these ones are drawn, OT intersects that at M, and then you have a tangent. So this word here, okay, big O. And then they're telling us that STK, that's a 36, okay. This is 18. Okay, first question, they want us to get T2. Okay. Now, one thing we know, before we get T2, if this is a radius, and then this is a tangent, we know that the tan and radius must be perpendicular. The tangent and the radius must be perpendicular. So which means T1 plus T2 must give us 90 degrees. That's what we got to start with. So I'm going to say T1 plus T2 is 90 degrees reason, the tan perpendicular to the radius. Okay. Then if I have T1 as a 36, then I can find 92. So 36 plus T2 is a 90, and then I'll transpose that. So which means 92 becomes 54 degrees. Okay. Then they want us to get L. So if this is a 54, this L, this is L here. Now, one thing we can also see is that since this triangle KLT is touching the ends of the circle, and this angle is between the tangent and the chord, it must be equal to that. So I'm just going to say that L is a 36. The reason is because of the tan chord here. Okay. That's going to be the tan chord here. And then with C, they want me to get the angle KOT. KOT. So this angle here. Okay. All right. So one thing I'm seeing, I don't want to overthink and what I'm seeing is that since this 36 is at the center, as at the circumference, and this KOT is at the center, it's forming that angle at the center is twice angle of the circumference, but in a flipped way. So this must be twice of this, since this is the angle, because the two angles are being created by the same chord. So which means KOT is 72 degrees. Let's see, angle at the center is twice angle at the circumference. Okay, so that is 8.1.2. We move 8.1.2. Can we prove that Km is the same as ML? Km is from here up here is the same as ML. Okay, so if this is a 36, this is a 54, one thing I'm saying that this line is common. Okay, I don't know, I would look at maybe trying to prove what do you call this thing? Congruence in this case. Because I can find what K1 is so that I focus on two triangles. So I'm focusing on this triangle. And then we're going to also focus on this one, look for what is common. And get the reflex to relate the two, then automatically that will be also the same. So what I'm going to get, let me try to find the whole of K. So K is going to be 54. The reason is going to be angles opposite equal sides. Because we know that this is a radius, this is also a radius. So this is an isosceles triangle. So this 54 must be the same as that was 54. Then if the whole of it is 54, then what is K1? That is 54 minus 18. Okay. So 54, come on, come on, come on. 54 minus 18, that's gonna give me 36. So K1 is a 36. Just K1. If there's a 36 here, then there's a 36 here. Then I can see that this is common. Then my question is, what is this angle here? Okay. What is that angle? Okay. So if I try to find this missing angle T2 and T3, I'm gonna look at the triangle KTL. So the 36 and a 36, which is a 72, which means that's gonna be 108. So angles in triangle KTL. If that is 108, but this is a 54, which means T3 is gonna be 54. So what I'm gonna do, I'm gonna say that T3 is the same as T2. Prove that. And then we see that L is the same as K1. We've also proved that. And then we see that TM is common. Okay. Therefore, KTM is congruent TML because of the two angles on one side. Say angle, angle, and side. Then if the two are congruent, then we can see that the side that is opposite the 54 is ML and that, which implies that KM is the same as ML. So that's how I would have gone about with that question 8.1.2. Start by getting these missing angles, prove the congruency, and then I'll draw the conclusion. So that is 8.1.2. All right, then 8.2, they're telling us that the diagram RDS is drawn. A, B, and C are points on RD. Okay. Such that that and that and that. AB is parallel to that. RB, the ratio of RB to BS is 5:3. And then BC, that's a 20. And then can we prove that BC is parallel to AD? Can we prove that BC is parallel to AD? So what I can do, for me to prove that BC is parallel to AD, I need to look at this triangle in this format. If the proportion, if my CS, let's say over CD, is the same as BS over RB, as long as these ratios are satisfied, then automatically they'll be parallel. Okay, so step number one. State number one. I'm gonna get CS. What is my CS over CD? That's gonna be 12 over 20. When I simplify that, I'm getting the 3/5. And then we know that BS over BR is also going to be the same as 3 over 5. Okay, so then I'll say, just write CS over CD is equal to 12 over 20, we get 3 over 5. Okay. And then we're saying that BS over BR is also 3 over 5. And then since CS over CD is the same as BS over BR, okay, therefore BC is going to be parallel AD. It's AD, but we also take it as DR. Okay. So, okay, so these two lines are parallel. The reason is going to be the converse of the proportionality theorem. Okay. So that is our first question. 8.2.1. Then 8.2.2, if it's further given that RD, okay, what's happening here? Now they're telling us that RD, the distance from here up to there, is 48 units. Is that true? Yes. Calculate the ratio of AD to AB. So the ratio of that to that. Okay, so what we're going to do, we know that AB is going to be the same as DC, because if that is, remember we've proved that these lines are parallel. And then initially they told us that these lines are also parallel. What does that make this whole ABCD thing? So ABCD is a term. It's a parallelogram, okay? So if AB is the opposite side of DC, so I'm saying AB is also going to be 20 units. Reason, opposite sides of a term or parallelogram. So if that is a 20, all I need to find is the size, okay? The size of AD. Then I can go back to my triangle RDS, okay? RDS, and say that from RDS, if I use my proportionality theorem, if I get my AD over the total distance RD, okay, AD over RD must give me the same thing as BS. Okay, just this, I'm comparing it. Okay, so I'm having BS over the total length, which is RS. Okay. The reason is going to be proportionality theorem, because AB is prior to, so AB is prior to DS. Okay, then I'll substitute what's my AD, that's what I want. So AD is going to be the same as BS times RD over RS. So our BS, we said was 3. And then I'm multiplying the 3 by the RD, which is a 48. And then I'm dividing it by 5 times 48. No, not a 5 times. It's not a 5, it's not a 5. RS is 8. So that is the total length. It was 5 and 4. Okay, so it means I'm having 18 units. Okay. If it's 18, which means the ratio of AD to AB I'm gonna have 80 is to 20. Because our AB was a 20. Remember, initially we said this. So when I simplify this, I'm gonna have 9 is to 10. So AB is AB. It's gonna be 9 is to 10. All right, guys, that is question number, number 8. Then question number 9. In the diagram, if O is the center of the circle, ABC is a cyclic quadrilateral. Let's remember the properties of a cyclic quadrilateral. This is our center. Can we use answer book to prove this theorem that the opposite angles B and D are supplementary? It's okay. Can use this. So in most cases, there is construction that is needed. Okay. So if I'm proving B and D, which means my construction, I can extend a line to O, then I can extend that. Okay. I can call this top part 1. I can call the bottom part 2. Then I'm gonna say that my O2, okay, because O2 is the angle at the center, which must be the same as 2 times B. So O2 is twice B. Reason is angle at the center, angle at the center, center. It's equal twice angle at the circumference, so we can write the full word. Then consequently, we can say that O1, this angle here, is also at the center. It must be twice the angle at the circumference. It's the same as twice D. So angle at the center is twice angle at the circumference. Okay. But we know that our O1 plus O2 must give us 360 degrees. Reason? Those are angles at a point. Or sometimes we just call it a revolution. Then when I substitute my O1 and O2, that's going to be my 2D plus my 2B being equal to 360 degrees. Vector out the 2, I'll have D plus B being equal to 360, and then I'll divide both sides by 2. So that I have my B plus D being equal to 180 degrees. So I think the proof is done. So angle B plus angle B must be equal to 180 degrees. So that is how you go about that. Okay. There are other ways, but I find that the easiest approach. The 9.2, since we proved about the cyclic chord, which means the second question, now you should be related to that. So in the diagram, DEFG is a cyclic chord. Okay, such that this EF is parallel to DG. And they're telling us H is another point in the circle such that this is parallel to that. Okay. Can we prove, given reasons, that D1 is the same as D2? Okay, so we know that opposite angles of the cyclic chord are supplementary. That is number 1, since we don't have anything like exterior angle here. Then we're gonna play around with parallel lines. So if I can find this angle, then I'm gonna need to get this G. And it is this G that will be the same as that to the ultimate angles. If that is possible, then I've proved my question. Okay, so step number 1, I'm gonna say that F is 180 minus X. Reason, opposite angles to the cyclic chord. Okay. Then if F1 is 180 minus, Then I need to find G. So I'm saying G is going to be X. Reason, these are co-interior angles. They are co-interior because EF is parallel to DG. Remember when you said if you have two parallel lines, this angle and this angle must add up to 180. Okay, so if this is 180 minus X, this is too small. Explanation. If that is 180 minus X, this is a second angle that we don't know. Maybe P plus 180 minus X must give us 180. That is the rule about co-interior. Then when you move the 180 that side, it's going to die out. You move the X that side, which means P is the same as X. That is the principle that we're using. So if G is X, then D2 is also going to be X. Why? Because these are alternate angles. This angle. So we're going to say alternate angles because DH is parallel to FG. Then if that is true, since D2 is X, come to a conclusion. Therefore, D1 is the same as D2. Yeah. Comments. Then question number 10. Question number 10. They're telling us that in the diagram, TR is a diameter. It's here. This is a diameter, that is the center of K. And then PRKT is a side plate chord. Let me just highlight that. It's the side plate for us. Okay. And then the chords TP and K are produced to intersect at the point base. It's fine. Chord PK is drawn such that PK, this one, is the same as this one. TK and PK. All right, okay. Then prove with reasons that SR is a diameter. The circle that is passing through SP. So if we have a circle that is passing through SP, what do we know about diameters? So for as long as we have a diameter, it simply means that the angle that is opposite to the diameter must be in. So this question is literally asking us to show that if there is a diameter. If you can prove that, answered the question. Okay, so what I'm going to do, how do we prove that P3 is 90? Okay, so I'll start by finding K. Remember, they told us that this is a diameter. Let me start from here. That is a diameter, and there is a proper circle that is within, sorry, a proper triangle that is within that kind of format, which means P1 and 2 is going to be 90. I can look at that, or I can say K1 and K2 is a 90. So I'll use the P1. So I'm saying P1 plus P2 is going to be 90 angle in a semicircle. Okay. So if that is a 90, which means that P3 is also going to be 90. This one is going to be angles on a straight line. Remember, angles on a straight line must be supplemented. So that we have this 90 of P1 and P2 and this 90 of P2. So if that is a 90, then that is enough to prove that if we add a circle here, okay, then this would be the diameter, since this diameter is opposite to the 90. So having said that, I can just draw that conclusion. Therefore, our SR, SR is a diameter, SR is a diameter. What was the question asking for? Can we prove that SR is a diameter? To that. Okay, so we proved that that angle is a 90. Okay, we proved that that angle is a 90, which means SR is a diameter, and we're gonna use the converse of what? The reason is converse of angle in a semicircle. That is one approach. The other approach was for someone who cut this K1 and K2, and then that 90. And if that's a 90, which means P3 is also a 90 because of the exterior angle of the cyclic quad. And then we draw the same conclusion. Then 10.1.2, they want us to prove. Can we prove that S is the same as P2? S is the same as P2. What do we do? What do we do? S is the same as P2. Okay. So from this drawing of mine, I can see that R1, this angle, is going to be the same as T1 and T2. Because that is exterior under the cyclic quad. Okay. And then, okay. Since they told us that TK is the same as P2, I'll start by saying that T1 plus T2 is the same as P1. Okay, this one is going to be angles opposite equal sides. Because when I look at this triangle, that is in triangle TPK. Okay, if that is true, then I'm seeing that R1 is going to be the same as T1 plus T2. The reason is going to be exterior angle of the cyclic quad. Then write it this side, same T2 plus T1 is the same as P1. Reason angles opposite equal sides. And then same R1 is the same as T1 plus T2 because of exterior angle of the cyclic quad. Okay. Then if that is true, that this and this are the same, and then that is also the same. What does this mean? This simply means that R1 is the same as P1. Does it make sense? Yes. Say P1 and R1, they are equal to the same thing. Therefore, P1 is the same as R1. Okay. Go further and see that in triangle is P. Remember this was meant in triangle is RP. We know that P1 and P2 are going to be named same as S and R1. Okay, let me start by saying P1 and P2. P1 plus P2 is equal to 90. Those are the opposite angles of the cyclic plot. If not, we will prove that the angles in the same side. Let's just stick to that. Okay. Angle in the same side. Okay, so if that is true, which means even S and R1. If this is a 90, it means S and R1. S plus R1 must also be 90 angles in triangle SRP. Then I can equate this two. I'll say, I hope it makes sense, guys, not one plus 5. P1 plus P2 is the same as S plus R1. But we say that P1 and R1 are the same. So this and this are the same, which means that P2 is the same as S. 10.1.3, 10.1.3. Question is asking us to prove that SPK is similar to PRK. SPK, just highlight it. That SPK, this big triangle, is the same as, which one is the black one? PRK. This one. Let me put that as okay. So from the drawing, I'm going to say that K2 is common. Okay, for both triangles, since both of them are sharing this K2. Then what we just proved was S and P2. The same S is the same as P2. S is equal to P2. We just proved that. Which means this is gone. So it means R2 plus R3 must be the same as P2 plus P3. The reason is going to be the remaining angle. All right, so same K2 is common. Okay, previous question, S is the same as P2. Same, we proved that up. And the R2 and R3 must be the same as P2 plus P3. Reason, that is the remaining just remaining, and it's fine. Therefore, having obtained that, yes, we have three facts. Then we can say that SPK is similar to PRK. The reason is going to be angle, 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 or you can just use triple A, no problem. 10.2. 10.2. It's further given that SR is the same as RK. At this angle, so that side is the same as this side. It's disorganized, but it's given use a clean one. Okay, so this is the same as that. Okay. Now they want us to prove that ST, can we prove that ST is 6? No, root 6. R what? Okay. Okay, so what I'm gonna first of all do is, since we're looking at ST, which is, and we know that K1 plus K2 is 90 because of angle in the same circle. Okay, that's 90, then this is right angle triangles, and we can apply the Pythagoras theorem. We'll have ST squared is equal to TK squared plus SK squared. Okay, but before I go there, let me first of all look at this triangle, the PSR and the friend. This is PSR, that is SPK. So if I have this kind of format, just gonna read through it. This is SPK. I know this is my P13. Okay. And I draw the small one. It's gonna be okay. Say K is common. Say P2 is the same as, so there's a P there. Say this is gonna be R. Okay, my question just has R. Okay. So I'm gonna try to eliminate PR. Is that even possible? It's possible. Very possible. So I'll ignore this side and that side. Let me try to look at this. So I'm gonna say SK over PK. It's gonna be the same as PK over KR. Okay, what's the reason? That's going to be the proportionality sides of sides and proportion. Proportion sides because of similar triangles. If I make PK the subject, which means PK squared is the same as SK times KR. Yes, I need it. All right, then I can just go back and know that our PK is the same as the TK from the question. Told that PK is the same as TK. So where I see a PK, I can replace it with a TK. So that I have my TK squared is equal to SK times KR. Let's get here. So this is going to be ST squared is equal to, where there is TK, I'm going to replace all of this. So that is SK times KR plus, what is our SK? They told us is the same as this. So if this is RK, this is also RK. So I'm going to say 2RK squared. But I know that the whole of SK is the same as 2RK, since this and that are the same. Okay. So which means ST squared is gonna replace this to 2, I don't know, RK is the same as KR, it's the same thing. Plus that is gonna be 4 RK squared. So ST squared is gonna be 2 RK squared plus 4 RK squared. And this is gonna be ST squared being the same as 6 RK squared. Then I take square roots on either side. Then that's gonna be root 6 square root of anything squared is just gonna be RK. So that is what we have to do. So start with the triangles and compare the proportions. Someone could have said SK over PK is equal to PK over that. That are the sides that are in proportion. So, guys, that's that. With that question 10.2. Oops, that's the last question. All right. So, guys, we're done. That was the last question, and then I'll stop. All right. Thank you very much, guys. So, if there are any corrections to be made, please, you can leave them in the comments. We appreciate your feedback that you give us. That will make us better people in the future. All right. Thank you very much.